Today's video is going to be on section 4.4, day 1, and we're going to be talking about derivatives of exponential and logarithmic functions. And so really what we're doing here is adding to your list of derivatives to memorize. So we're going to give you some new rules, and then as always we're going to do some practice. So the first thing we need to do here is clean up this notation a little bit. We need to change these to be the derivative with respect to x. So go ahead and please make that change in your notes. So these should all be d dx, so the derivative with respect to x of these functions. So now the first one is the derivative with respect to the x of a to the u. And a note here I want to make is that a is a constant. So we may have a function, for example, like 2 to the x. And so our derivative here is going to be a to the u times the natural log of a times du dx. And remember again, this du dx is really just accounting for anything that might trigger the chain rule. So in other words, if our u here is anything other than just x, we're going to trigger use of the chain rule. Our next function is log base a of u, and that derivative is going to be 1 over u times the natural log of a times du dx. Next is our function e to the u, and this is actually an easy one to remember. That derivative is just itself. So the derivative is e to the u, and again times du dx if we need chain rule. So for example, our most basic function, if I'm taking the derivative with respect to x of e to the x, that derivative is just e to the x. And then last but not least, we have the derivative with respect to x of the natural log of u. That derivative is just 1 over u times du dx. So those are 4 new rules that you need to have memorized, and we'll go ahead and do a little bit of practice with those right now. So the first one's really easy. Our function is e to the x, and we actually just talked about that one. So our derivative is just e to the x. And since x is by itself, we don't have to worry about chain rule for this problem. And actually for these first 4, we won't need to worry about chain rule at all. Our second one, we have f of x equals 3 to the x. So that's actually our first rule here, because remember we said a is a constant. So now my derivative, I know my a is 3, so what I'm going to have is 3 to the x times the natural log of 3. And that's my derivative. For number 3, we have the derivative of the natural log of x. So this derivative is just 1 over x. And then our last example for this section, we have log base 4 of x. So we're using our derivative here. So I'm going to have 1 over, my u in this case is just x, and then I have times the natural log of my base a, which in this case is 4. And that's my derivative. So again, we didn't have to worry about chain rule for any of these examples. That, however, is going to change with this next set of examples. So our derivative rules are going to be the same, but now we have to account for the chain rule. So number 5 is f of x equals e to the 2x. And again, this 2x is what's going to trigger that chain rule. So for the first part of this, I just take my normal derivative. And again, if we look back here, we said our derivative of e to the u is just e to the u. So my first part of this is just to still take e to the 2x. It's going to stay the same. And now I'm going to take the derivative of 2x, and there's the chain rule piece. So times 2. And so my derivative is 2 times e to the 2x. For number 6, here's my exponential function. So g prime of x, we said was going to be a to the u. So this is still going to stay the same. So I'm going to have 4 to the 2x plus 1 times the natural log of 4. And now I have to multiply by the derivative because of this right here, which is going to trigger the chain rule. So I'm going to multiply by 2. So what I have is 2 times 4 to the 2x plus 1 times the natural log of 4. Now we're going to go a couple steps further with this, because most likely if this were a multiple choice question, this answer would not be one of the choices. And so what we're going to do, I see I have 2 here, and I know that 4 can be written as a power of 2. So I'm going to take this a step further and say this is 2 times, and what I really have is 2 squared to the 2x plus 1 times the natural log of 4. Well, I know that if I take a power to a power, I'm going to multiply those exponents. And so in this case, since I'm multiplying 2 times the sum of 2x plus 1, I'm going to distribute those exponents. So what I have is 2 times 2. And again, I'm going to distribute this 2. So I have 2 to the 4x. And then if I distribute to the second term, I have plus 2 times the natural log of 4. And then for the last step, I know this base 2 has an exponent of 1. So if I'm multiplying a power times a power, I know I add those exponents. So I can simplify this to be 2 to the 4x plus 3 times the natural log of 4. Okay, for the last 2 on this page, my next one is natural log of 4x plus 5. So here, if I take the derivative, I know the derivative of natural log is just 1 over the argument there, so 1 over 4x plus 5. And then again, I'm going to take the derivative of my inside, so times 4, and my derivative is just going to be 4 over 4x plus 5. All right, sorry, I had to pause it there so I didn't cough into the microphone. Last one for this page, we're going to find p prime of x, and we have our logarithmic function. So we are going to have 1 over our u, which is 2x minus 1, times the natural log of our base. And now here we have to remember that if it's not specified, or if it's not actually listed there, then our base is 10. So 1 over the difference of 2x minus 1 times the natural log of 10, and then the derivative of our inside is just 2. So our derivative is going to be 2 over 2x minus 1 times the natural log of 10. So those are our basic logarithmic and exponential derivative rules. So let's keep going. Here we're going to get into some slightly more complex problems, and some that look complex but really aren't. So for number 9, here we have y equals e to the x plus x squared. So this is really not too bad. Our derivative is just e to the x plus x squared, and then we know to account for chain rule, we're going to multiply that by 1 plus 2x. And that's all we need to do there. That's just a one kind of chain problem. Same thing with the next one. Here I have my exponential. So I know the derivative of 2 to the t is just 2 to the t times the natural log of 2. Derivative of negative 3 is 0, so we're done. The next one, however, has a little more going on. So I'm going to color code this so we can tell what's going on. So again, when we have multiple chains, we're working from the outside in. So if I look at this one, I know my very outside function is this logarithmic function with base 2. Working in, I have some exponential function, 3, and that's raised to the sine of x, which is its own layer that we'll have to deal with when we take derivatives. So let's see how this all comes together. So for our derivative, dy dx, first we're going to take the derivative of our logarithmic function, which we know is 1 over, we're going to take 3 to the sine of x, times the natural log of our base, so times the natural log of 2. So that's the outside. So now we have to start differentiating the inside, which is 3 to the sine x. So now I'm going to do 3. The sine x is going to stay the same. And I have times the natural log of 3 from the derivative of that exponential function. And now I can take the derivative of sine, which is just going to be times cosine of x. So now I notice that I have a 3 to the sine x in my denominator and my numerator, so I'm going to cancel those. And then just doing one simple simplification, I'm going to have natural log of 3 times the cosine of x all over the natural log of 2. And that will be our final derivative. So the only piece left for this then is to put these rules together with our product and quotient rules. And so that's what we're going to do to kind of close out the video here. So my first example, I have a product rule. So I'm going to take my first function, e to the 4x squared, times the derivative of my second, which is a nice easy power rule problem. And then I'm going to add the product of my second function and the derivative of my first. So this is e, my derivative will be e to the 4x squared. And then we do chain rule and multiply by the derivative of 4x squared, which is 8x. So I'm going to get 20x cubed times e to the 4x squared plus 8x e to the 4x squared times 5x to the 4th minus 4. Now, we could leave it there, but again, I just want to practice simplifying because most of the times these will be multiple choice questions, and I want us to be aware of how the answer could look on a multiple choice test. So just to make this a little easier to see, I'm going to kind of box my two separate terms here. And we're going to pick out what's in common between those two terms, so factor out those common factors. So between my 20 and 8, I'm going to factor out a 4 out of each term. I have an x and an x cubed, so I can take out an x. And then in both, I have e to the 4x squared. So now, I know here I'm going to need to multiply by 5x squared, and that'll complete my first term. And on this side, I need 2. And then I just need my 5x to the 4th minus 4. So I'm just going to take this one step further, 4x times e to the 4x squared. I'm going to leave that outside. I'm going to distribute inside. And there is my derivative. So again, I actually don't mind you leaving it at this stage. This shows me how you know to take that derivative. But again, if it were on a multiple choice test, we need to make sure we can simplify it down to this level here. All right, so for our last one, we're going to do a quotient rule problem with these derivatives. So I have my low d high minus my high d low, and so here I'm going to have 1 over 2x to the 5th, and then doing my chain rule piece, I'll have times 10x to the 4th, and that's all over natural log of 2x to the 5th squared. So now I'm going to do a little simplification here. If I have 10x to the 4th over 2x to the 5th, I'm really going to have, these are going to cancel and give me a 5 on top. And then my x to the 4th can cancel, and I'm going to have a 5 in my denominator. So I'm going to write that so it's a little more neat. Okay, sorry, I had to pause that again. I'm having coughing fits. Okay, here we go. So we have 4x times the natural log, excuse me, of 2x to the 5th, minus, now I have 5 over x times 2x squared plus 3, all over my denominator squared. And so now to get rid of that fraction, I'm just going to multiply my top and bottom by x. And so I'll end up with 4x squared times the natural log of 2x to the 5th. When I distribute to this term, that x is going to cancel. So minus 5 times 2x squared plus 3, all over x times the natural log of 2x to the 5th squared. And that will be our derivative. So that's all for today. Obviously, we'll keep practicing with these tomorrow. Get to work memorizing these derivatives.